Hello CTM students, welcome to the lesson for 11.2 on personal loans and simple interest. Got quite a few new vocabulary words. I would guess maybe a few of these or a couple of these you recognize, you could give a definition in your own words for, but a lot of them I bet are new terms for you, so make sure you look at the list, you understand those by the end of this lesson, and use those extra examples in your book. There's a couple of types of examples that I won't go over. I'll just refer to them in the book, but most of them we will hit here. So let's check this out. Let's first of all define some things, some important things here to start. And a little bummed about the fact that I was not able to import any pictures for this one. My internet here at school where I'm currently filming this is it's down. I don't know what's going on, so we're just going to have to make do. I might draw some pictures off to the side over here just for fun. But simple interest formula. I'm boxing this in with a big box because this is pretty much the most important thing in this whole lesson, that you know this formula right here, this simple interest formula. The formula is just this: interest, so the amount of interest on a loan or on something, we're talking about personal loans here, is going to equal the principal. Doesn't look very good. Principal, that's a weird looking eye right there. There we go, principal. Now, I'm not talking about the principal of our school here, even though that is spelled the same way as this, but principal times rate, the interest rate, in other words, times the time that you have the loan out for. So a quick way to write this, we will abbreviate it like this: I equals P R T. Written all together just means P times R times T. Principal times rate times time. Make sure you absolutely positively get that memorized. Very, very important for this lesson and this chapter even. So knowing what those letters stand for. Principal, let's define what that is. You could say principal or you could say credit. You would hear one or the other. So if something's given to you on credit, that's money lended to you. You have to pay that back. You got to pay that money back or they're going to come after you. But money lended to you. So this is going to be definitions in kind of my own words. You can see slightly different worded definitions in your book if you want to check those out. Security, in terms of loans, what does that mean? Security, or you might hear the word collateral. So you put something up for collateral. That something is valuable, something that they will take from you if you do not pay the loan back. So it's something of value the lender gets if you don't repay the loan. The lender gets if you don't repay the loan. Another term we need to know or be aware of what it means: a cosigner. It's just like it sounds. Somebody would sign something and then somebody else would co-sign with you. So a cosigner is someone that signs a loan agreement. Someone that signs a loan agreement. And that loan agreement, so I'll underline that too. I think that's something we should know, even if that wasn't in the vocabulary explicitly. So a loan agreement, sometimes we would call that a personal note. Personal note. A note in loan terms is just like a description of the loan. So it's a personal loan. It's your note. It's your loan. Agreeing. So this is back to the cosigner now. So someone that signs a loan agreement agreeing to help pay the loan if you can't. So I would imagine many of you thinking of going to college, you might get a cosigner on a college loan. You might not have to do that, but you might have to do that. Who knows? You might co-sign with somebody for a home mortgage. When you buy your first house, somebody may co-sign with you as kind of a backup to you, but be careful of that. Don't co-sign on somebody's personal note if you can't actually pay for something yourself, because you could get in trouble yourself. And interest, what is interest? Money you pay I'll put in exchange, you could say in return. What do you pay in exchange for the use of the lender's money? So you got to pay that lender's money back in full, and then that with interest. So they're not just going to give you that money for nothing. They expect a little something back in return for that. And then one more thing up here before we do our first example that we need to know. So I'm going to put a little star next to this. This is pretty important here. For the purposes of computing ordinary interest, so if you hear that phrase, ordinary interest, you should think that you're doing this, what I'm going to write below here. So purposes of computing ordinary interest, 1 month is going to be 30 days. So if they say 1 month and they're talking about ordinary interest, that's just referring to 30 days. We're not going to differentiate between 30, 31, and 28 days and 29 days for a leap year, February, if you're computing ordinary interest. We're just going to all assume that 1 month will be equivalent to 30 days, and that 1 year will equal 12 months, 12 of these 30-day months, which would be 360 days. So ordinary interest, we think of it like this, we think of it like this. So let's work on an example at this point. You are borrowing $5,000. You are borrowing, the B right there, borrowing $5,000 to pay for a car. Suppose you get a 6-month loan. It's a pretty fast loan for $5,000, but let's suppose that's the case. Suppose you get a 6-month loan with an annual simple interest rate of 7.2%. You might be able to do better than that. Kind of depends on where interest rates are at the point in time that you get the loan. But we'll say that's what it is for now. Calculate the simple interest on the loan and determine the total amount paid back at the end of 6 months. So $5,000, 6-month loan, 7.2%. And what are you going to pay back? The total amount paid back at the end of 6 months. So we know we have to pay this $5,000 back. And we know we have to pay a little bit of interest on top of that. So your final answer should be a little bit over 5,000. We're just going to use this equation, so going back to here. So it's a simple interest question. Use the simple interest formula. I equals P times R times T. And what is that going to equal? What is the principal? The principal right up here, which you borrowed, was $5,000. That's the amount you borrowed. This number is going to be 0.072. You may ask, where did that come from, Mr. Wagner? That's right here. So this is the point where you get out your different color, put this in a different color here, that this 0.072 is the same thing as 7.2%. So we saw that in our last lesson. We just moved the decimal 1, 2 spots. That's why we did that in our first lesson for this chapter, we're going to have to deal with percentages quite a bit for this personal finance, consumer mathematics type chapter here. And then this number is going to be 0.5. Now that one might be initially like, what is going on? That would be confusing to me too if I just saw that and didn't get an explanation. So where does this come from? Write this in a different color up here as well. It's a 6-month loan, and there's 12 months in a year. Aha, so maybe now you had that aha moment, because this is the same as 1/2, which equals 0.5. Why are we doing something like this? So this is 0.5 years, I should say. So this is 0.5 years, and we're talking annual up here. So I want to underline that word in the different color too. That's why annual years, they go together. So annual thing is in years, 0.5 years is what goes in for your T. At that point, it's a matter of taking out a calculator and just calculating that out. So let's do that right here. We have 5,000 times 0.072 times 0.5. That's going to be 180 exactly. Sometimes it will be a rounded off answer, but this one happened to be 180 exactly. This is in dollars, $180 interest. So this is $180 in simple interest. This would be one part of our answer here. It's one part of what they asked for. And the total amount, the total is going to be the principal plus the interest. So $5,000, the amount we initially borrowed, plus the $180 would be $5,180. That's what we'll have to pay back. So let's continue with a second example here. And let's say we have Tony the Tiger. So I wanted to have a picture of him, but sorry, he's not there. Just pretend he's there. Pretend you're eating some Frosted Flakes. Tony the Tiger, poor guy, fell in some hard times. Tony the Tiger decided to pawn his silver cereal spoon. Try to say that 20 times fast. Silver cereal spoon for, we're going to say $420. After 60 days, he was able to scrounge up some money. He got his spoon back. His beloved spoon that you see on all those Frosted Flakes boxes. He got his spoon back by paying the pawnbroker. So a pawnbroker is a guy or a gal who would work at a pawn shop. Pawnbroker, $520. So he had to pay $100 more just to get it back after essentially 2 months here. So what annual interest rate did he pay? What annual rate of interest did he pay? So this could be his silver spoon. I'm going to try to draw a little drawing of that over here. Okay, forget the drawing. So what annual rate of interest did he pay? So pretend he's got this spoon. He brought it to the pawn shop. Maybe this could be a little pawn shop like this. So he went to the pawn shop. Poor Tony the Tiger. He went in there. They snookered him. They got him for quite a bit of money there, but he was just on tough times. He needed that money, and so what's he going to pay? So we have that same equation, I equals PRT, and what goes in here. So before, over here, we knew everything but the interest, and we're trying to here figure that out. Or actually, we're not trying to figure that out. I'm sorry. The interest amount we know this time. So we know we can fill that in with this 520 minus 420 would be 100 in a different color. Add that in right here in a different color. This is where this came from. It's 520 minus 420. This principal, what did he start with? He started with $480. That was the principal that he had to pay back. So he borrowed $420 in exchange for his silver spoon. The rate, that's what we're trying to figure out. What is the annual rate? So we're going to leave that as an R. And then the time, T, we know would be 60 out of 360 we're using for this type of problem. So we're saying that 1 year is 360 days for this ordinary interest type problem here. So this is going to be 1 over 6. Where did that come from? We would have to know that this came from this idea that you had 60 out of 360 equals 1 over 6 right there. So that's why that is what it is. From that point, now we work this out. So we have 100 equals, and then we can switch the order in which we multiply. I can multiply this times this first if I want to. So that would be 420 over 6. You could make this a fraction if you wanted to. You could put it over 1, but you don't have to. You can just think of it like that. I'll do that kind of small there. So 420 times 1, 1 times 6 on the bottom. 420 divided by 6 equals 70. 42 divided by 6 is 7, so that's 70. So you have 70 times R, or in other words, just 70R. You can think then at that point, divide by 70, both sides by 70. And why don't I do that? I'm going to do that in a different color here, so please do the same. So divide by 70. Just to see that that 70 wasn't there, we are solving the equation for R. So we have R is 10/7. This would cancel out here and here. And then that, you're not going to say there's a 10/7 rate of interest. That's not going to make sense to somebody. So you would make that a fraction. 10 divided by 7 gives you 1.43 rounded off to the nearest hundredth. That's what I'll go with for now. So 1.43. Kind of just depends on what they say in the problem. Now this is not the rate of interest. 1.43 is not the rate of interest. You got to move that 2 spots to get the rate of interest. Rate of interest is always going to be in a percent. That is pretty crazy. So they are charging you an annual rate of 143% interest. That means if you kept this money for the whole year at that same rate of interest, they would charge you $840 plus an extra 43% on top of that to get your money back. Pawnbrokers, unless you are in a desperate situation or unless you just don't want to get your thing back, don't make the deal. So if you are totally desperate, that's the only time you should be going to a pawnbroker, I would say, ever in your life. So I'm not saying that this is necessarily what always happens, that they always charge this much interest, but pawnbrokers definitely charging a higher rate of interest than normal places that you might be able to get a loan from. Let's define one more term here. I'm going to move this down just a little bit, not by much. Actually, I'm going to go back to the previous slide. I have some room here. So yeah, I'm going to define this towards the bottom. I need that. I think I might need that full space for the next example. So a discount note, this is just a little extra tidbit here. A discount note would be this. It's a loan where the interest is paid upon receipt of the loan, or upon receiving the loan, in other words. So upon receipt of the loan, and the interest charged is called a bank discount. It's called a bank discount. And then this one, I'm not going to go over an example like this one. If there is a problem in your assignment that you need to do like this, I want you to refer to this example in the book just to make the time of this video a little more reasonable. It's similar to what we just did here, just a little twist to the action there. And so just a little more description with that. A Federal Reserve Treasury bill, that is often a bank discount note that's issued by the U.S. government, just like our book says there. And if you're taking out a discount note, a loan like this, basically if you were borrowing $1,000, you're only going to get a certain part of that $1,000 as your loan. You're paying the interest up front. So if the interest was like a 10% annual rate on that $1,000, you're going to pay that $100 on the 10% of the $1,000 up front. So you're only going to get $900 back as your loan, and then you just need to pay that $1,000 back later on then. But we'll skip that for now here and get into this. So if you have a problem dealing with discount notes, see that example on page 605 in your book. But partial payments, another thing we should know how to calculate, how to figure out. So sometimes you may be able to pay part of the loan off, but not all of it. Or you may be able to put a down payment, kind of in a sense, or in other words. So let's say not you buying, but you're buying. Say you're buying a new big screen TV. Congratulations. So you're buying a new big screen TV for $1,750. It's a pretty penny right there. Or a pretty silver spoon maybe. You don't have enough money. So you don't have enough to pay for it all up front. But lucky for you, the store has two payment options. The first requires, so the first option, the first requires a down payment of $500. The down payment, if you haven't heard of that phrase or that phrase before, that would be just money you're putting down before getting any sort of loan. So you're paying this up front, $500, and then $1,500 in 6 months. The second, or in other words, the second option, the second requires a down payment of $700 and then $1,250 in 6 months. Which option has a higher simple interest rate? Because in a perfect world, or in a mathematically intelligent world, you would want to figure out which one has the lower interest rate and try to use that if at all possible, because you would be paying less interest that way. So which option has a higher simple interest rate? You want to pick the one that has the lower one if you could. So you may notice $1,750, wait a minute, 500 plus $1,500, that's $2,000. That's more than $1,750. Yeah, that's the whole point. They're making money on you if you have to borrow money. This plus this is $1,950. So they're, again, making money on you with this option as well. They're not just going to give you the TV and say, oh yeah, just pay us back when you get around to it. They're going to have some sort of set in stone way in which you have to pay this back. Whenever possible, you should try to buy things with cash or with money you actually have. If you don't have the money for it, and it's not something like a college education, or it's not something like a house, and you don't have the money for it, you should not be buying that thing. That's just my personal opinion. We have so many people just up to their eyeballs in credit debt, credit card debt, and whatnot. These things I'm showing you here, this is kind of like how it works out. Hopefully you can see that, hey, this doesn't seem like that good of a deal. They're really making a lot of money on me. That's right. That's how they stay in business, some of these places, is that they charge you these exorbitant amounts of interest and just go from there and kind of just take you apart pretty much. Take all your money from you if you're willing to give it to them, just because you wanted that big screen TV. But let's start working this out. So where did this number come from? This 250. This is, we're talking here, we're going back to this equation. I'm just not writing it down. I'll write it down here. So I'll write I equals P RT, just so you know where that came from. So I equals P RT. This is the interest with option 1. So here's option 1. I will do this in my different color here. So please write this down in a different color as well. Where is this number coming from? The interest is, well, here and here, you're paying them $2,000 for something that should only cost $1,750. 2,000 minus 1,750 is 250. So that's where that came from. This is 500 plus 1,500 first, and then subtracting from that, you're subtracting 1,750. Write that down for me first. And then the principal, the rate, and the time. The principal here, I'm going to erase this because I need a little bit of space here. I wanted to write some stuff here. So just know that that is where these numbers are coming from. The I equals PRT. This is going to be 1250 right here. Why is this the principal? Well, you are paying, you're paying $1,750, or that's the amount you should have been paying straight up for the TV. You gave a down payment of $500, so the principal, the loan that you're taking out is $1,250 plus the $250 interest that you have to pay back in addition to that. So this right here, this number comes from that idea. It's $1,750. It's the amount the TV originally cost minus the $500 down payment. So that is your principal in this case in option 1. We're taking that times the rate, and I'm going to call this R with a little 1. This is a subscript, so R sub 1. It's not a power, it's beneath. It's written small and beneath. Just standing for rate with option 1. And then this times 1/2. Where's the 1/2 coming from? This 1/2 is coming from, it's a 6-month deal. We're saying what one has a higher simple interest rate. We want to figure this out annually. So this one is 6 over 12. That's where that number came from right there. So color code these things for me, put those in the different colors. And then we work this out from here, calculate what we get. So this is 1250 times 1/2. We could consider that first as 625 multiplied by R1 for rate number 1. Take that, divide it by 625. Yeah, I'll do that in a different color too. So let's do that in a different color. 625 divided by 625. Get that to cancel out. So you're left with just plain old rate 1. If you put this into a calculator, you get 0.4. Just double check that here, make sure I did that right earlier when I was working through the problem. Yep, 0.4 is rate 1. So what is that as a percent? Move that decimal 2 spots, you're going to get 40% interest rate. That's pretty darn high. I think I'd rather use a credit card because most of them have these annual percentage rates of about much less than this. So the store is really making a good deal for themselves right there if they're going to charge you that much. Option 2, what's the interest that they charge here? Well, they charge this much plus this much for a TV that's supposed to cost this much. So how much more are these two added together than this? That would be 700 plus the 1250 minus 1750. That's going to be 200. So again, this is principal equals, or interest equals principal times rate times time. I equals PRT. So I'll color code this part now again. This number is coming from the fact that 700 plus 1250 minus 1750 equals 200. And then the principal, excuse me, will be $1050 because you got $1750 for the original and you made a down payment of $700. So this is $1750 minus $700 right there. That's where that number comes from. And then times your rate. This will be the rate with option 2, so I'll put a little r, put lowercase r with a small 2 written subscript wise next to that. And then this times, it's still 6 out of 12 months, so that would reduce to 1/2. You could write it as 6 over 12 first, then multiply it through later. So this comes there, and this comes there. I will have you add this up here. So one last thing to include there, that's 6/12. So we have 200 is going to equal half of 1050 is 625, not 625, 525, sorry. I was looking at the previous one. 525 times R2, and we would divide now. Let's put that in a different color here. Divide by 525. That to cancel here. Divide by 525. It'll cancel out there. And so you had $200 interest that you're paying, and you're dividing that by 525. This, I'll take out my calculator here. So 200 divided by, not 2,000, 200 divided by 525 equals 0.3809. So if you round this to, we'll round to 4 decimals. That's pretty common with interest rate problems. So this would be 38095. That would round this up to a 0, which would round this up to a 1. So 0.3810 would be to 4 decimal places, the nearest 10,000. So 0.3810 is approximately your interest rate for the second option. And that as a percent, which is what we want to use to compare, 38.10% for option 2. Which one is higher of these options here? That up a second. Which one's going to be higher? Option 1 is just a little bit higher. So option 1 is, I think, the worst option of the two. I think they're both terrible options, honestly, because those are really, really high interest rates. But looking at that one and that one, if you had to choose which one you'd want to do, you'd want to use option 2 because it has a lower interest rate. So option 1 is higher. So I hope that big screen TV is worth it to you if you're going to take out a loan for something like that. Okay, let's define a couple more things here. The United States rule. So there was this, I believe it was a Supreme Court decision back in, let me look that up again a second. So a Supreme Court decision, yeah, I don't know what year it was, but the United States rule, you could look that up if you're curious enough, but the United States rule came from a Supreme Court decision that specified the method by which payments are credited. So to make it fair for everybody, basically, they came up with this law, this United States rule. The Supreme Court says if a partial payment is made on a loan, interest is computed on the principal of the loan until the date of the partial payment. Seems fair. The partial payment is used to pay the interest. First, is used to pay the interest first. So the partial interest in a sense, Then the rest of the payment is used to reduce the principal. So if you borrow, let's say $1,000, but then maybe you got a gift for your birthday, some money for your birthday, $200, you pay $200 to your lender, whoever gave you the loan, and they're going to first kind of calculate the partial interest up until that point, take from that $200 of partial interest, and then reduce the principal from there. So maybe the interest you got knocked off was $20, and so you got $180 left over. That goes towards the principal, thereby reducing the interest you're going to pay for the remainder of the loan. And we'll do a couple examples that show that a little more specifically. That might have been a lot to take in there all at once. So the banker's rule, one other rule, a little shorter here. When computing interest with this rule, with the banker's rule, computing interest with this rule, a year is considered to have 360 days instead of 365. So 360 years, whoa, 360 days. And any fractional part of a year is the exact number of days. And any fractional parts of a year is the exact number of days. Right. And so for example 4, let's put this into the context of some examples, these two rules. Use table 11.1 to find, say it has two parts here. Part A, the due dates of a loan made on April 25 for 90 days. And then part B, we're going to find the number of days from July 11 to November 19. Now, if you ask yourself, what the heck is table 11.1? What are you talking about? That's a great question, because we haven't showed that to you yet, or I haven't showed that to you yet. So let me bring that up just a second. Right, so here's parts A. We're talking April 25 and then 90 days after that. So what's the due date? What is essentially, what is 90 days after April 25th? And so to do that and do that exactly is kind of tedious. You'd have, without some sort of table to look at, because you have to figure out, okay, which months have 30 days, which ones have 31. We're calculating this exactly. So let's write down April 25 is the same thing as day what of the year. That's what this table 11.1 is going to help us do. Hey there, table 11.1, how are you doing? Nice to see you. Thanks for stopping by. So April 25, here's April, and here's day 25. So I'm going to circle these things. I'll erase that in a second. You don't have to write this table down. This will be a table that's provided for you come test time for my class. So April 25, this is not something you got to try to memorize or write all this down. That's going to be day 115 right there of the year. So January 1st is day 1. Go through that. You got 31 days. Notice it does say add 1 day for a leap year. If February 29 falls between the two dates in consideration, under consideration. So if you're talking a loan that goes through February during a leap year and goes through that February 28, 29 range, then you would have to include an extra day. This would become day 61, day 62, day 63, and so on there instead. But we're going to consider this to not be a leap year most of the time here. So let's go back to this problem. This one, it doesn't really matter if it's a leap year or not, because April 25th falls after February 29, potential February 29, and 90 days is not going to get back to February from there. But this was day 115. And then 90 days after that, so this is important to think of this number. I'm going to circle that. It's important, not our final answer yet, but important to think of. That's where this comes from, this 115. So I'm going to take this now, put that plus 90. You've got plus the 90 days right here. So plus 90, this would equal day 205. So go back to the table now, day 205. What day of the year is that? And so there, table's right here. And so going to, now let's get rid of this stuff just to make it a little more clear, I think. That should help. Okay, and we're saying where's day 205? So day 205 is right here. And then going to the left, that is day 24 of what month? Of July. So this is July 24 for our final answer for part A. Simple as that. July 24 is 90 days after April 25th in the table. So that would be your due date if that was your type of loan, something like that. Part B, you are saying the number of days from July 11 to November 19. So same idea. July 11, you're going to look it up in the calendar, look it up in the table rather, and figure out what day that is of the year. So July 19 or July 11, sorry, July 11. Here's 11th day of July, that's day 192 of the year. And then November 19, here's November, here's the 19, that is day 323 of the year. So we'll go back to the problem now. So we have day 192. And November 19, I'll abbreviate that like that. November 19, day 1, day 323, there we go. And then 323 minus 192, that's the difference in your days. That would be a kind of a strange time period for a loan, but a 131 day loan if you were to have a loan spanning from July 11 to November 19. So 131 days, something like that with that problem. Let's get rid of the annotations there. There we go. And let's check out a fifth example here. Determine the simple interest that will be paid on a $1,200 loan at an interest rate of 7.5% for the period February 3 to August 15, using the banker's rule. So using that idea that each year will be 360 days, using the idea banker's rule going back to your 360 days. Any fractional part of a year is an exact number of days from this table. So using the banker's rule. And one more thing, we'll assume it's not a leap year. So assume it is not a leap year. So we won't be adding an extra day to our table. So what is February 30? I said 13. February 3 is, if you look at the table, here's day 3 of February, that's 34 right there. So that's day 34. How about August 15? Here's 15. Here's August. Line those up. You got 2/27. So day 227. For August 15. If we take these two values and subtract the smaller from the larger, that will give me the difference in days between those two dates. So this is 193 days. If we do that, that's pretty darn important to answer this question. Now we are calculating the simple interest on this loan. So now we do our I equals P R T part. The interest is going to equal the principal times the rate times the time. The principal, the amount of the loan, is $1,200. The interest rate, as a decimal, move it 2 spots, you have 0.075 instead of 7.5. And then this, here's where we're using the banker's rule. We're dividing by 360. So I have 193 divided by 360. Put this in a different color for me right here. Why this and this match up, or how that came to be. The banker's rule here means we divide by 360. So that goes with that part right there. Then it's a matter of putting that into a calculator. And so we have 1,200 times 0.075 times, and then I'm going to put 193 divided by 360 in parentheses. I want that to multiply together first, and I'll hit equals. That should do the whole thing there for me. And this one is exactly, works out pretty nice on that, or in this case, exactly $48.25. This is the simple interest that will be paid. So you're paying this back, you're paying this much interest, plus you have to pay that loan back. Don't forget about that. You didn't just make out with $1,200. You didn't just get that scotch-free. They got to pay that back. So you're actually going to be paying back $1,248.25 total back for that loan. And then now a final example. Example 6. This one, I think, a very, very practical problem here to end up. So Bob takes out a 240-day loan for $2,200, and we're saying this guy, he just got engaged. So here's his engagement ring. That's looking pretty nice. Oh yeah. Look how shiny it is. Oh, it's sparkling all over the place. It's just radiant. Okay, it's $2,200 engagement ring right there. For an engagement ring. Let's keep writing engagement ring. At an interest rate of 9.2% on November 3rd. So he decided he wanted to get that ring on November 3rd. He uses a bonus from his work to make a partial payment of $1,000. So he got a pretty nice bonus check over the holiday season there from his work on, we're saying January 5. So he cashed that check, bonus check. He got that much. He paid off some of that debt that he had incurred. And so we're going to break this up into 3 different parts here. Determine the due date of the loan. Determine the due date of the loan. And write this down too. We're going to assume once again that it's not a leap year. So assume It's not a leap year. So what day is November 3rd going to be? What day of the year is that? Let's go back to our table and calculate that. So November 3, here's the third day of November right here. That is day 307. So day 307 is what we'll put right here. And then going to January 5, that's going to be the 5th day of the year. I hope you can figure that out without too much trouble. That's the first month, so we don't really need to look at the table for that one. Now, what are we doing with these two numbers? I'm not subtracting 307 from 5. We're assuming it wasn't a leap year. So to get to the end of the year, first we would need to take 365 and subtract that 307 from it. That's how many days it'll be to the end of the year, to December 31st. And then 5 extra days to get to January 5th. So plus an extra 5. That's where that's coming from. This would be 58. 58 plus 5 would end up being 63 right there. And then from there, we can now figure out, determine the due date of the loan. We can now figure out a little bit more here because we have our 240-day loan. That's what we have here. So we're taking our initial day, day 307. I'm looking at the wrong part of my paper here. Just a second. There we go. I am actually doing the wrong part of this. This is going to be for part B. So why don't I just save this for later? So profuse apologies for that. I'm just going to see if I can move this down. This will go with part B. Hey, I'm missing part of the equal sign. Okay. So we will have to do this later. Some of the stuff we have to still do here. So this November 3rd part, that part can stay. November 3 is still day 307. I need to know that for sure. And then I need to know what's 240 days after that. So my fault on that. You may have wondered where I was going with that. So 305 plus 305. 307 plus 240 would be day, in a sense, day 547. Let's put this in a different color here. This is 240 days later. So 240 days after day 307, after November 3rd. But we need to know what day of the year is that. So we need to think, okay, take this, it's more than a year, so this is kind of like a little throwback to our last chapter with the modulus. We can think of getting rid of mod 365 or doing that mod 365. What's my remainder if I get rid of as many multiples of 365 as possible? So minus 365 would give me day 182. That's what's left over. Day 182, go to your table now and find what's day 182. Here's 182 right up here. That's July 1st. And so what goes here is, this is going to be July 1st. So let me just circle that right here. Why did we do minus 365 right here? Let's make some notes here that this is days in a year. So that's where that came from. We want to subtract that 365. This was the day it was going to be after 307. And so we'll have that as the same thing as day 182 in the year. So July 1st is what that is. Part B now, this might be in almost exactly the right spot right there. So determine, we now know the due date. Now we're going to determine the interest and the amount credited to the principal on January 5. So that is when we made this partial payment. We didn't pay off the whole loan then. We made a partial payment on January 5 of that right there. So November 3, day 307. January 5, day 5. I'm going to leave that right here. This is something I needed to calculate. And 63, you can pause this if you need to copy that down quick, but 63 is part of what I got here. I'm going to move this up just a little bit. 63 is the number of days from November 3rd to January 5th. Important to know that to be able to figure out what the interest is that you will have to pay during that time portion, during that time period from that day to that day. So the interest is principal times rate times time. Principal is 1,000 initially, or the amount you paid. So we're paying $1,000, and then 9.2% is the same as 0.092, and then we're using that banker's rule. It's 63 over the 360 we're saying for the year. So this came from right there, and then this, if you calculate that, you end up getting exactly 16.1, which is the same thing as $16.10. So this is your interest. That's going to mean I'm going to need another page here. So 1610. And so we have 1,000. We paid $1,000, but $16.10 of that was going towards interest. That means you have $983.90 is credited to the principal. So this much gets chopped off the original $2,200 that you got for the loan. So you had to pay the $16.10 in interest for that partial payment, 63 days there, and then the rest goes towards paying off the loan. And you're not going to have to pay interest on that $983.90 anymore for the rest of the days. That's the nice thing about paying this off partially early. So it's credited to the principal. Meaning now we have this adjusted principal. We have less than we had to pay total now than before. So the adjusted principal is now $2,200 minus $983.90. So what you owe now on the loan, what you still owe, is $1,261.10. So this is going to be important for the next part. I did that calculation for this last part. Part C. Determine the amount Bob must pay on the due date. And so we know now, basically we have think of it as a brand new loan almost, starting at January 5 is the day of this the day of this $1,261.10 loan. So starting at day 5, and then we figured out before that July 1st was my due date of the entire loan. So July 1st, that was the same thing, as day 182. The difference between these two numbers, quick calculation, gets you 177 days. So the remainder of this, if you think back to what we just did here, 177 plus the 63 days here, so 63, let's write that in here too, 63 days, 177 plus 63, that should equal the total number of days of the loan. If you add 177 plus 63, you get 240 days, which would make sense. That partial payment time from 63 days and then the rest of the payment time, 177 days, should add up to the total. And so now we have interest is principal times rate times time. The new principal, the adjusted principal, comes here. Let's underline that here in red, or circle this in red, or whatever color you're using, and let's bring that through. I'm going to go wrap around here, and that comes in right there. So just make a note of that. That's where that number came from. That's our adjusted principal now, times the same interest rate as before, times 177 over 360. That number coming from right there. Put this into a calculator. You're going to get, I'll do this one with you. So 1261.1 times 0.092, and then times, I'll put this in parentheses, 177 divided by 360. So that's 177 divided by 360, and then that all multiplied together, $57 and about 4 cents. This would be rounded off to 4 and not 5 cents. So approximately $57.04 interest. So not quite my final answer there. This is interest on top of the extra principal that he still has to pay, the adjusted principal. So finally we have our final answer here. We have $1261.10 plus the $57.04 in interest that he paid is going to equal $1,318.14 more total that's due on July 1st, which is the due date. And that is a wrap for this lesson.